Hello, my name is Nicholas Lunt, and this is an introduction to polybutylene succinate. What is polybutylene succinate? Polybutylene succinate, or PBS for short, is a biodegradable polyester that stands out in the field of sustainable materials. It's synthesized from renewable resources, primarily succinic acid and 1,4-butadiol, which can be derived from the fermentation process using sugar or biomass. What differentiates PBS from conventional plastics like polypropylene or polyethylene is that it's both bio-based and biodegradable, which offers a full life cycle alternative to fossil fuel derived polymers. As concerns grow around plastic waste and microplastics, materials like PBS are becoming crucial for eco conscious packaging, agriculture, and consumer goods. Now, what are some examples of polybutylene succinate products? Well, PBS has found its way into many practical real world applications due to its balance of mechanical performance, thermal stability, and biodegradability. In the food and beverage industry, it's used in coffee capsules, cutlery, straws, and disposable plates, which replace petroleum based plastics for single use items. Now, it's also used for paper coating, which provides moisture resistance for paper, which is very important for beverages or food based paper items like trays, cartons, drink containers, things of that nature. Um, there's also the flexible packaging products, which contain things such as sugar pouches, mulch films, grocery bags, even cereal liners or cereal packaging, where these uses are not just practical, but strategically targeted to reduce plastic waste and products that are often discarded very quickly. Now, what are some physical properties of polybutylene succinate? Well, the melting point of polybutylene succinate is 115 degrees Celsius, which allows it to retain shape under heat in conditions for its products, which, for a hot liquid like coffee or like hot foods, there's things for the trays, right? It'll prevent it from melting. It's very useful for it as a polymer. It also has a density of 1.26 grams per centimeters cubed. This makes PBS a lightweight and very similar to other polymers such as polyethylene or polypropylene, and it's very useful for the manufacturing of such products because it's very similar to other well-established polymers. It's also for its solubility in water, it's insoluble, which is a vital for any packaging or food contact applications where moisture resistance is critical, like water cups or trays. Now, the solubility in chloroform, it is soluble, which makes it very useful for processing and recycling in controlled environments like industrial processes or lab experiments or anything like that. These features highlight PBS's viability as a drop-in replacement in various plastic applications. Now, onto the mechanical properties of polybutylene succinate. Mechanically, PBS performs quite well, especially for disposable or semi-disposable products, which are usually very flimsy and weak. Now, a yield stress of 40 megapascal means that PBS can resist deformation under moderate load, which is similar to polystyrene, but as an environmentally friendly product, is very good. Now, its flexural modulus is 630 megapascals, which indicates it's stiff enough to hold form, but it's not too brittle that it's going to crack, which allows flexibility under vending, which is very useful for utensils, containers, and films or other products. Its flexural strength is 40 megapascals, which reinforces that it's not going to bend and crack, and it's just going to bend and keep form. The Rockwell hardness of PBS is 107, which shows it's very durable against surface scratching and denting, which helps items maintain integrity throughout use. Altogether, these make PBS suitable for functional, sturdy products that still degrade safely at the end of their life. Now onto the chemical structure model for butylene succinate. Now this is one subsection of polybutylene succinate, just the butylene succinate molecule, where the red atom is oxygen, the blue atom is carbon, and the green atom is hydrogen. This is what the structure looks like. Now on to the next slide, the PBS degradation pathway. PBS is made from the PBS has a favorable degradation pathway, allowing for the breakdown of the polymer to be environmentally friendly, where PBS degrades via hydrolytic degradation, than enzymatic degradation. Hydrolytic degradation occurs by water molecules attacking ester bonds, forming succinic acid and 1,4-butadiene. And then enzymatic degradation follows with PBS breaking down from microbes in the soil, which produces water, carbon dioxide, and methane. Now we want to know, how is polybutylene succinate produced? We know it's produced it's bio-based, but how? BBS is produced by polymerizing succinic acid and 1,4-butadiene. Succinic acid is typically made through microbial fermentation of carbohydrates such as sugar, starches, like potatoes, corn, wheat for starches, or sugarcane and sugar beets for sugar. It ferments along with glycerol to make succinic acid, which is very useful because both are bio-based products and allow for a very environmentally friendly reaction to occur. And now we're on to the conclusion of polybutylene succinate. Well, PBS offers a powerful combination of performance and sustainability. It behaves like a conventional plastic in strength and handling, but it's made from renewable resources and biodegrades naturally. Its use in food packaging, coatings, and compostable items make it a key material in addressing plastic pollution. As we move forward toward a circular economy, materials like PBS give us a real scalable path forward. Thank you for listening to my presentation.